Hello guys, welcome back to our Guiding Wind implementation Unity video series. In my previous video, I implemented the method to turn the direction of a wind zone towards the objective's position so that the player is guided by the wind zone's direction to move towards the objective's position. At the moment, whenever I press the Z key of my keyboard, the wind zone's direction snaps from one direction to the other. This is not quite natural or believable within our game scene. So we can create some kind of a transition from one direction to the other within our game update. If we could smoothly increase the intensity of the wind and smoothly reducing it while our is guiding state is true. Before creating that, let me toggle this is guiding variable to true whenever I call the start guiding wind method. And inside our is guiding state, we will increment a floating point variable. Let's call it guide ticks. Okay. Inside our is guiding true state, we will increase this guide ticks value by the delta time value, which means in each frame update call it will read the delta time value and add to our guide ticks variable. We will need some kind of a maximum or limit so that whenever this limit is reached for the guide ticks, we can close this is guiding true state to end our wind guiding state. Let's say we have a variable called max weight, then we can restrict the value of the guide ticks variable into the max weights value. Let's create a floating point value called max weight, and I'm going to assign it to 10. So whenever our guide ticks goes more than 10, it stops at 10 from this ternary expression that I just created. And if the guide ticks reaches the max weight value, then we can close this is guiding state by assigning false to this is guiding variable. Right. We can actually check our logic using before that, let's reset our guide ticks variable whenever I call this start guiding wind method. Now let's use a debug log statement within our update method so that we can identify whether our states are working as we are expecting in our set of logic. So whenever the guide ticks value is increasing, we should see this wind guide active with the guide ticks value in our console. And if we reach the end of our is guiding state, then this debug log call should be logged into our console, which is wind guide ended. Right. And let's add another statement here to check whether the starting also happens accurately. Let's call it wind guide started. Right. So let's save our script and move to Unity editor, and we have to open our console here. Let's clear this up and go to play mode. Okay, so if I press the Z key, I can see wind guide started logged in our console, and then we have wind guide active going, and then okay, we have wind guide active with 10 and wind guide ended. So our logic is working as we expected. In the update loop, you have one start call, wind guide started, and during the wind guide active state, the guide ticks increases up to 10, which is the max weight value, and when it reaches 10, we go to wind guide ended and closes off the guiding state. Right. And also, if we keep pressing Z key again and again, it won't actually uh, restart our wind guiding logic, because if is guiding variable is true, then the method actually returns without executing the resetting lines. So we have only one statement during each wind guide state. Okay, we have blocked out some state that is enabled whenever the wind guide mechanic is enabled, and inside that state we have a variable that is increasing over a certain rate. So what if we could assign this guide ticks value to our wind zone's main value or turbulence value or other wind zone properties? Let's try assigning this guide ticks to our wind zone's main value, which is wind main. I am resetting this value in the start guiding wind method, and in the update method I can assign this guide ticks value into the wind main property. I am just copying this value and assigning this directly to the wind main property. Right. Let's see what happens in our game play view. So if I press the Z key, it's not very noticeable, but you can see the wind zone is actually gradually increasing with time. If you check the inspector's main value, you can see it's increasing and it stops at 10. The main property is now at 10. But still, this increasing behavior is very linear. Let's try assigning the turbulence value with the guide ticks variable. I am assigning the guide ticks to the wind turbulence property in our wind zone. And let's reset that as well in our start guiding wind method. I am setting that property to 0 as well in this method. Okay. Now if we check play mode, yeah, this view is much clearer than before. I'll keep using this top view to examine the wind behavior. So if I press Z key, okay, the main value and the turbulence are both increasing up to 10. Okay. Now the increasing behavior added a little more believable look to our wind direction or the wind's directing behavior. So if we check this again, you can see the wind zone's intensity is gradually increasing until it stops. Right. Right now our guide ticks are increasing in a linear fashion. We are just incrementing it over the delta time value. We can further smoothen this increasing behavior by using a Smoothstep function in our update method. In case you are not familiar with what Smoothstep means, it is a family of sigmoid-like functions which has a smooth increasing behavior rather than linear incrementing behavior. Other than this smooth interpolation, there is a special property in this Smoothstep functions. The x value or the value that we pass as a parameter has a limit. It is restricted to a certain minimum value and a maximum value. We call it the right edge and the left edge. If the input value or x is equal to the left edge, then the output is 0. If the input value is equal to the right edge, then the output is 1. Which means the input value should be restricted between a certain limit, and always the outcome or the output value is between 0 and 1. We'll have to modify our guide ticks changing behavior to match this properties of a Smoothstep function to implement this behavior in our guiding wind script. In this definition, we have 3x squared minus 2x cubed Smoothstep function limited between 0 and 1. We can apply this Smoothstep function into our code. First, let's define a floating point value for our Smoothstep value. And we have these guide ticks restricted for a value between 0 and max weight. We'll have to normalize this value to take an input value between 0 and 1. So I am going to divide this guide ticks value by the maximum value guide ticks can get, which is the max weight. Let me copy this line so it will be easier. I paste this and we divide the guide ticks value by the max weight value. Now the smooth step value or the input value is something between 0 and 1. Now we can process this smooth step value inside the smooth step function, which is 3x squared. We are using smooth step instead of x, minus 2x cube. Okay, this is straightforward. You can understand what's happening here. We are using this smooth step function to calculate the smooth step value for our increasing behavior. Now let's try using this smooth step value to manipulate the wind main property and wind turbulence property of our wind zone. Let's save this script and go to Unity play mode. I'm going to initially set these properties to 0 so that it is more clear. At the start of the game you won't see any wind since the properties are 0. So I have to press the Z key. Okay. Yeah. You can see the main property and turbulence property of the wind zone are increasing, and now it stopped at 1. But in our Unity scene it's not very noticeable. Yes, we can see the trees swaying, but the values are not increasing to a noticeable value. So how can we scale up this value instead of increasing up to 1? Let's try having a couple of public variables so that we can scale up these property manipulating values as we want. Let's make a public float for main values multiplier, and I'm going to assign 10 as the initial value, and another public float for the turbulence values multiplier. Let's call it turb multiplier, and I am assigning 10 to there as well, right? And here, instead of directly assigning the smooth step value, I am multiplying the smooth step by the multiplier value, right? And if we go to Unity play mode, this should be noticeable in our play mode. Let's go to play mode now. Okay, and press the Z key. Okay, now we can see the wind is increasing to a higher value, and also it stops at 10 in the inspector. both main value and turbulence are stopped at 10. Right. Now our wind zones values are increasing smoothly as we want. Now we should implement a method to decrease this value slowly to mark the end of the guiding wind step. Okay, I am using this online curve plotting tool called fooplot to visualize my smooth step function. You can see it actually increases from 0 to 1 in the usual manner. We can flip this function upside down by subtracting this outcome from 1, and now we have a decreasing behavior. So if we can implement this additional behavior inside our guiding wind state, then we can smoothly decrease the wind intensity as we want. I am creating an additional field to remember the initial value of our wind zone's intensity value for each property. For an example, for the main value, I am creating this wind step left. Left means the left edge value of this smooth step curve. So for each left edge, I am creating a field in my code. In my start guiding wind method, I'll reset these left edge values to 0, because when the guiding wind starts, the wind intensity that I want from this uh, behavior starts from 0. So the left edge is 0 when this method is called. Instead of changing these properties, I am going to uh, reset the left edge values in my start guiding wind method. Now when we reach the max weight value in this guiding state, let's check whether this wind was increasing or not. We can condition this value, or we can check this uh, state by checking whether the multiplier value is positive or negative. Then we can flip the sign of these multipliers and decrease the wind value as we want. So I am choosing the main multiplier value to check whether the wind was increasing or not. If this main multiplier is positive, then the guiding wind was increasing during this time. Then I'll flip the sign of these multipliers inside this if condition. I just multiply it by -1. Okay. And then we can assign the left edge values to the maximum values that the wind zone reached at the end of this step, which is the left edge value plus the multiplier, because the multiplier was uh, applied to a number which was increasing from 0 to 1. Then the maximum value is the multiplier itself. Actually, this is something common to this reaching max weights condition. We'll have to do this even in the decreasing side as well. So we can take this outside and set these values whenever the guide ticks value reaches the max weight value. Okay, now then we if we were decreasing this wind, then the main multiplier should be negative, which is triggered by this else block. Then we can disable this state by setting the is guiding property to false. Now if the wind was increasing, when the max weight value is reached, the multipliers toggle to negative values, and if the wind was decreasing, the state just closes. Additionally, I am assigning these left edge values to the wind zone's uh, main wind main property and wind turbulence property. Right. But still there is something missing here. We didn't reset the guide ticks variable in this reaching max weight state. We have to add this as well inside this region. I think we can actually use this as a common execution, just like uh, defining these left edge values. Whenever the guide ticks value goes to the max weight value, the guide ticks value should be set to 0. And then we will do the conditioning whether the wind zone was increasing intensity or whether it was decreasing. Now I want to check whether my logic is valid within the game loop. So I am using these debug log statements for this checking purpose. Now my multipliers are toggling its sign during the guiding wind state. So I'll have to reset them as well. In my start guiding wind method, I am checking whether they are negative, and if they are negative, I can revert them back to the positive value by multiplying it by -1. This will be done to both main multiplier and turbulence multiplier values. And then I can assign these reset initial values to my wind zone properties as well. Now in our Unity play mode, let's check our behavior and see whether it's smoothly increasing and decreasing. I have pressed the Z key and you can see the smooth increasing, and now it's decreasing smoothly to halt at 0. Right. Now we have a manageable state that has a smooth transition from 0 to 1 and back to 0 inside our guiding wind uh, state. We can add some more polishing by changing different values inside this state. For an example, we can change the max weight value so that we can uh, quickly increase the wind intensity and slowly decrease the wind intensity to make it look more natural. Let's try it by making a public float value for the entrance time and for the exit time. When our guiding wind starts, it should be the max wait time should be the entrance time, and when the multipliers flip, this max wait should be the exit time. So here, when we are flipping the multiplier values, I am assigning the exit time to our max wait, and when the guiding wind starts, I am assigning this entrance time to our max wait value. Now we can use these public variables, entrance time and exit time, to manage how the wind increases and decreases over time. We can slowly decrease the wind intensity when the state is exiting, and we can increase the wind's intensity fast during the initial stages. So this wind transition looks more natural. Also, I have to mention that I used only the main value and the turbulence value, the two properties in the wind zone, to change during the wind guiding state. I didn't reach pulse magnitude and pulse frequency. We can change those values as well to add more effects to this wind zone. So I thought of adding more fields to manipulate or change the pulse magnitude and pulse frequency of our wind zone. We can assign the smooth step values and use new left edge values and repeat the process again for these two properties. It's better if you can decide which values are best for these multipliers by editing this wind zone in your play mode and copying the values later for this script component. I took some time modifying the wind zone's properties in play mode to come up with some good values that I'm happy with uh, for this guiding wind zone. You can see if I walk around away from this objective, this wind changes the direction and also smoothly transitions between 0 and the max value. And there is one thing missing right now in this uh, small level. Whenever this guiding wind is not present, the trees are always still. So we will have to address that problem as well. We can create another wind zone inside this scene that actually acts as the environmental wind that keeps blowing regardless of you are using the guiding wind or not. I'll rename it as environment wind, and I'm renaming the previous wind zone as guiding wind. Okay. You can use or even modify these values as you want. So now you can see the trees are actually moving even when I'm not using the guiding wind. Yes, the leaves are moving. It adds more natural look to our scene with the existence of this extra wind zone in the sea. I thought of modifying this script's use of wait time or the max wait variable in a different way. Instead of changing the max wait variable, we can actually change the rate of uh, increase that is put upon the guide ticks variable. Right now we are increasing it by only the delta time value. If we can further scale this value by some sort of a rate, we can speed up the wind's increasing rate and slow down the decreasing rate without changing the max wait value. When the guiding wind starts, I am going to assign an entrance rate for our transit rate variable, and I'm going to remove the max wait value assigned. And when the multipliers flip, I am going to assign the exit rate for the transit rate variable, and this value is multiplied with the time dot delta time value for the guide ticks. And I'll remove the entrance time and exit time variables from this script. Okay, now we can switch to play mode and change these exit rate and entrance rate as we want. Okay, that pretty much completes our smooth transition of wind from one value to the other. So I'm going to stop this video from here. See you guys soon with the next video on this guiding wind mechanism implementation to show how we can improve this mechanism further to look more natural and interesting. Thank you guys for watching, and see you.